Alrighty, in this video I'm going to go over the solutions to the FRQ problems that you were assigned today. Please review these before your test tomorrow. Alright, for the first problem, 1995B6, we have a hollow tube of length L open at both ends as shown. It's held in midair. The tube is held in midair. A tuning fork with a frequency F0 vibrates at one end of the tube and causes the air in the tube to vibrate at its fundamental frequency. I'm definitely going to underline that. Underline F0, length L. Express your answers in terms of L and F0. Okay, determine the wavelength of the sound. Well, this requires us to do a little sketch of what we see. So I'm going to redraw this tube over here because then it's going to be easier to visualize what's actually happening. And I will draw the wavelength in green. We know that it's vibrating at its fundamental frequency, and so if this tube is open and open, its fundamental frequency, because we know it has to go from one antinode to another antinode, is going to go a little bit like this. Oh wow, that's not very good. Yeah, I'll fill that in. So we got one node, and then one antinode, then one antinode. Now, what we see here is that this is half of a wave, right? So we need to go 1, 2, to go all the way to complete one wavelength, because we have one loop right over here, like kind of on a little bit displaced, but we need to complete two of these to get one wave. And so we can see that L is going to be equal to 1/2 wavelength here. Now if L is equal to 1/2 wavelength, then wavelength is going to be equal to 2L. That is the wavelength of the sound. That's our answer to A. Now for B, we want to determine the speed of sound of the air inside the tube. Alright, well if we want to determine the speed of sound, we know that we're always going to be using this formula. V is equal to F times lambda. In this case, we know the frequency is F0. We know that lambda is 2L. So if the frequency is F0, and we know that lambda is 2L, we got ourselves a pretty simple equation right over here. Speed of sound is 2L F0. Determine the next higher frequency at which the air column would resonate. Okay, for the next higher frequency, we know that for the next higher frequency, we know that the air column has to be, look something like this.